Hi Daniel. To decide which results to use in this table, you have to pick results that are within zero point 0.1 of each other. And you use the word concordant to describe those results. So looking at the data you've got, I can see that one and that one are both within 0.1. So they're the ones I would use to work out the average volume added. So the average would then be 26.2 plus 26.1 divided by 2, which is going to be 26.15 centimeters cubed. Okay, so the next stage is you're told that the standard solution is 0.1 moles per decimeter cubed, and you need to check, we normally take 25 centimeters cubed of that when you do your titration. You've been asked to find the concentration for the acid, so we don't know that, but we just worked out that the volume added is 26.15. The equation for the reaction with the sodium hydroxide and acid is here. We need this because we can see that there's one mole of sodium hydroxide reacting with 1 mole of HCl, so the ratio is 1 to 1. I don't know what you've been taught, but when I teach my classes, we use this triangle to work out these type of calculations. So you can see you've got amount, concentration, and volume, and this means that you get the different factors in the right order when you do your calculations. We'll come back to that in a second. So let me show you the first one. So the first step in this calculation is to find out number of moles of the sodium hydroxide that has reacted. Okay, so we want to find the number of moles, which the number of moles is actually the amount in this triangle. So I'm trying to find the amount. So the amount is going to equal concentration times volume. So the concentration is 0.1 and the volume is 25 centimeters cubed, but we have to remember to divide that by 1,000 because concentration is measured in decimeters cubed. This is centimeters cubed, so we have to convert it into decimeters cubed, and to do that you always have to divide by 1,000. So if you put that into your calculator, you get 2.5 times by 10 to the power of minus 3 moles, and that's the moles of the sodium hydroxide that have reacted. So the next stage in the equation is to use the ratio from the balanced equation, and we had 1 mole of HCl reacting with 1 mole of sodium hydroxide, as you can see here. So we've just worked out that we've got 2.5 times 10 to the power minus 3 moles, and therefore, because this is a 1-to-1 ratio, we will have the same number of moles of HCl. So the final stage, stage 3, is to now try and find the concentration of HCl. So concentration, according to my triangle here, is amount divided by volume. So let's put that here. Concentration is amount divided by volume. The amount is 2.5 times by 10 to the minus 3 divided by, now the volume is what we worked out earlier on, 26.15, and then we have to divide that by 1,000 again. So let's do it on my calc, 26.15. And that's giving me an answer of 0.096 moles, and that's a concentration, so it's moles per decimeter cubed as a final answer there. So in this second one, I think they're asking you to use your answer from this first part to then use in this second part. But it wants you to work out, decide which ones you're going to use first, or which ones you're going to use. Same rules apply. You need to use results that are within 0.1 of each other. So I would use these two results because they're the same as each other. So your volume is 27.3. So if I just come back down here, I'm assuming that is your, I'll do it in different colours so we can see the difference. I'm assuming that is your HCl. So you've got 27.3 centimeters cubed. We just worked out the concentration of that, if it's the same solution you used, is that. And you will have reacted it with sodium hydroxide. Normally, again, use 25, and we're trying to find out the concentration of that. So going through the steps, we start this time with the acid because we know two things about it. So moles of HCl reacted. So this is the amount. So if you go back up to our little triangle, finding the amount is concentration times volume. So we've got concentration times volume, which is 0.096 times by 27.3. But remember, that has to be divided by 1,000 to get it into decimeters cubed. I should put that into my calc. So 0.096 times by 27.3 and then divide it by 1,000 is 2.62 times by 10 to the power of minus 3 moles. Okay. Step 2 is the ratio. The ratio again is 1 lot of HCl is equal to 1 mole of NaOH. We've just worked out that you've got that many moles of HCl, so it's going to be the same number of moles of NaOH. And then the final step is to work out the concentration of NaOH. So you're going to do find the concentration. So concentration come back up here. Concentration is amount divided by volume. So we can come back down here and we say amount divided by volume. The amount this time is 2.62 times 10 to the power minus 3 divided by the volume, which is 25. Remember, divide by 1,000. Again, put that into your calculator. Let's just do it. So it's 25. And I'm getting 0.104. In fact, make that 5 because we round up. Moles per decimeter cubed. Okay. So in terms of the graph, what you would have normally is pH against volume of the HCl added, and this is a pH curve. You start with the alkali, so your pH, when you plot it, will start off up here, and it'll stay the same as you can see for a period of time, and it'll drop quite drastically and then kind of level off down here. And what you normally do is you kind of extend that line, extrapolate that line, and extrapolate that line, and then you work out that distance between those two lines. And whatever that distance is, you half that distance, and you use that then to find the midpoint of that, and that then is the should equal the volume of acid added when your pH was 7. Okay, so just a case of extend the line out, extend this line out, find the distance between those two lines, half that distance, and then plot that pH, and then come down and find the volume that you've got there.